Hello everyone, welcome to Think Computer YouTube channel. In this video I will explain about floating point numbers and floating point arithmetic. So there are two type of real numbers. Okay, one is called fixed point real number and another one is called floating point real number. Okay, let's take example. Example of fixed point real number will be 20.58. Okay, so in a fixed point real number we basically have two parts. This part is called the integral part of the real number and this part is called the fractional part of the real number. Another example we can take is minus 10.24. Okay, in this number minus 10 is the integral part and 0.24, that part is the fractional part. Now what is floating point real number? Well, if I want, I can represent the same fixed point real number in a floating point format. How I am showing you. The number 20.58 in a floating point real number format will be 20.58 into 10 to the power 0. Okay, so this is how we represent a fixed point number in a floating point format. Similarly, minus 10.24 will be minus 10.24 into 10 to the power 0. Now please note that since it is decimal number, that is why we are using 10 to the power anything. Okay, if it is binary number, then we will use 2 to the power anything. Okay, in case of octal it will be 8 to the power, in case of hexadecimal it will be 16 to the power. Now let us understand the components of floating point real number and why it is called floating point real number. What is the special thing about this? Okay, so in a floating point real number, the number itself has three components. Okay, let's take the same example, 20.58 into 10 to the power 0. In this example, 20.58, this part is called the mantisha. Okay, this is the base of the number and this is the power. Now the question is why it is called a floating point real number. The answer is it's called a floating point real number because we can shift the point towards the left side or right side by adjusting the power. Okay, that means 20.58 into 10 to the power 0 can also be written as 2.058 into 10 to the power 1 and can also be written as 205.8 into 10 to the power minus 1. Now what is the rule over here? Well, the rule is if you are going to shift the point towards the left side, that means you are going to decrease the value of the mantisha, so you have to increase the power value. Okay, similarly if you are going to shift the point towards the right side, that means you are going to increase the value of mantisha, so you have to decrease the power. Okay, now in floating point real numbers we also have a standard format. The standard format says that the value for the mantisha between 0 to 1. That means if I want to write the same example 20.58 into 10 to the power 0 in a standard format, then I have to write it as 0.2058 into 10 to the power 2. Why did I make it 10 to the power 2? Because I shifted the points towards the left side by 2 places, so I have to increase the power by 2. Okay, so this example here is a standard floating point real number. Okay, now we are going to do arithmetic of floating point numbers, that means addition of floating point numbers and subtraction of floating point numbers. Okay, so suppose there is a question given, add 1011.110 into 2 to the power minus 1 with 100111.1101 into 2 to the power minus 2. Okay, first thing is that you will notice that now I have written 2 to the power. Previously I was showing you examples of 10 to the power. Like I said, those were examples of decimal numbers. In case of decimal numbers we use 10 to the power anything. Okay, but here it's binary number as you can see, so it will be 2 to the power anything. So the first thing is, if you want to perform arithmetic on floating point numbers, you have to bring both numbers to the same power value. That means you have to make both numbers either 2 to the power minus 1 or 2 to the power minus 2. But we can do one more thing, we can bring both numbers to 2 to the power 0. So if I want to make the power value 0, that means I am increasing the power from minus 1 to 0, that is by one place. So the point will shift to the left side by one place to adjust that. 101.1110 into 2 to the power 0. Understood? So whenever you increase the power, you have to shift the point to the left side, and whenever you will decrease the power, you have to shift the point to the right side. Okay, so it is now in 2 to the power 0. Similarly, the second number, that is b, we have 2 to the power minus 2. If I want to make it 2 to the power 0, that means I have to increase the power by 2. So the point will shift to the left side by 2, making it 1001.111101 into 2 to the power 0. Okay, so I have increased the power by 2. I have shifted the point towards the left side by 2 places. Now how do we do the addition? Simply just write down the numbers in this way. You have to align the points. Okay, that means that second number's point will come over here, and the value was 1001, that I will write here, and the fractional part is 1111 and 01 into 2 to the power 0. Then it is normal binary addition. Okay, so 2 to the power 0 will be there, and this 1, this 0, then 0 plus 1 is 1, then 1 plus 1 is 0, that carry 1, then 111 will be 1, that carry 1, then 111 will be 1, then carry 1, 111 will be 1, then carry 1, that will come down. So you will bring the carry from the fractional part to the integral part. That's not a problem. So this is the answer. Let's see one more example. Okay, suppose it is given 1000111.10 into 2 to the power, let's say 2, minus 10111.110 into 2 to the power, let's say 0. So in this example, the second number is already in the 2 to the power 0 format, so I just need to convert the first number. The first number, what I can see is 2 to the power 2. So if I want to make it 2 to the power 0, I am doing what? I am decreasing the power value by 2. So I have to increase the mantisha by shifting it to the right side. The point will shift to the right side by 2 places to adjust that. So the number will become 100011110.0. This 0.0 I have added right now. And the second number, that is not changed. Okay, so if I want, I can just align the points and write. This point will go there, and then 110 into 2 to the power 0. And in the integral part, we have 111, then 0 and 1. Now you can put zeros here in the fractional part. Okay, that will help you. So let's do that. I'll put zeros over here in the fractional part, 2 zeros. Okay, similarly here I can put zeros. Okay, so in integral part of the number I can put zeros. Leading zeros will not be a problem, you can write it there. And in the fractional part, trailing zeros you can put. Okay, so now it's 0 minus 0 will be 0. 0 minus 1 we have to borrow, so we will borrow from this one. All middle zeros will become 1. Okay, then 1 minus 1 will be 0, point will be there. 1 minus 1 will be 0. 0 minus 1 again we have to borrow, so we borrow from here. Again 0 minus 1 we have to borrow, so we borrow from here. And 1 minus 1 0, and rest will write down. So this is the answer.